Hello, everyone. Thank you so much for joining us for today's webinar, Orchestrate Resource Provisioning with Terraform and Bolt. My name is Simone, and I'll be moderating today's session. Before I hand things over to our presenter, Cass, I wanted to address a few quick housekeeping items. So first of all, we would love to hear your questions. Please feel free to send them over throughout the webinar. You can use the Q&A panel, and we'll save some time at the end to address as many as we have time for. You should also see a resource list panel on your screen where we've included links to some of the resources that Cass will mention during the webinar, so you can bookmark those and access them afterwards. And finally, I wanted to let everyone know that we will be sending out a copy of the recording and the slide deck within the next few days, so keep an eye out for that in your inbox. And without further ado, I'll turn it over to Cass to introduce himself and get us started.
Good morning, everyone. My name is Cass Donahue. I'm an engineer on the Bolt team. I looked it up yesterday, and I've been working on the project since 0.19, so pre-1.0. We are currently at 1.40, though today it might be 1.40.1. In the last couple months, the Bolt team and I, in particular, have been working on a plugin system for dynamically creating inventory. And an inventory, as we'll see, is a concept for Bolt to keep track of what targets it's connecting to. So one of the things that I particularly have been working on is an interface for Terraform. So today we're going to go through all the changes that have been going on with Bolt and the improvements to the Terraform module that we've been working on. So let's start with a quick intro. What is Bolt? Bolt is basically, we joke, it's SSH in a for loop. Of course, it's much more than that. But we can connect over SSH, WinRM, PCP, which is the Puppet Control Protocol, Docker we have a transport for, and we have a remote transport as well. So these transports enable us to execute commands, scripts, or what we call tasks on remote systems, which are great building blocks, but the real powerhouse is the Bolt plan. The Bolt plan is what allows us to orchestrate actions that happen over nodes or remote targets. We can even use plans to apply declarative Puppet code. Now, what is Terraform? Terraform is a tool for writing declarative manifests that are backed by providers that will allow us to manage infrastructure and write it and control it as version-controlled code. So Terraform is amazing at building and provisioning resources in data centers. However, one thing that we've noticed, and we think that Bolt is a value add, is we can use Bolt to orchestrate the provisioning and destroying of things. So that's what we're going to go over today. So specifically, we're going to go over how to discover EC2 instances running in AWS using the Terraform plugin. This will give us a sense of the concept of inventory in Bolt and how we can dynamically discover targets. We'll go over how to use Bolt to trigger Terraform runs within a plan, and we'll also see, basically, we'll go in depth a little bit into the task plan interface available within the Terraform module. Finally, we will show how to dynamically create new targets within a plan. So the concept there is, with the plugin system, we can dynamically discover things that are currently running, but then during the plan execution, if we're destroying and creating new things, we need to be able to manage our inventory to keep up with the changes that have happened. So I figured the probably most interesting thing to do here would just be to demo something. So I've come up with a scenario, and granted it's somewhat of a toy example, but this is something that I noticed on Terraform GitHub issues people have struggled with in the past, with basically a solution for this. And so the scenario would be, I have some web servers running on EC2 nodes that I'm managing with Terraform. Similarly, the load balancer servers are managed with Terraform as well. And all that exists in a data center, specifically US West 2. Instead, I would like the web servers to be running in the East Coast data center. So what I would like to do is provision the new web servers in the East data center, make sure they're configured with the software that I need to run my services, and then I want to remove the West target servers from the load balancer, and instead have the load balancer push the load off to the servers in the Eastern data center. And so this is a situation where we need to orchestrate the creation of new resources, the configuration of those resources, and then the destruction of the no longer required resources. So with that, we'll move away from slides and we'll get right into the demo. So just for what people are used to working with AWS, this is just my console showing you the instances that I have. And you can see that I have 3 servers running in the US West 2 Oregon location. I just wanted to kind of put this out there to kind of link in where people who use AWS might be most familiar. So how did this get created? Well, it was managed with Terraform, I said that. So this is the Terraform manifest that was used to create those resources. I'm not going to get too much into depth on how to write Terraform manifests, but I will go over the high-level sort of description of what's going on here. Again, this is declarative manifest-style code, so much like Puppet. You see we have a provider, AWS, which is configured with variables. Obviously, I can't share my access key here. And then further, we have an AWS key pair. So this allows us to have a way to securely connect with the servers we're bringing up. Similarly, we configure a security group, and our web server will be just on port 80. So we open that up, as well as port 22 for SSH. So here's the real meat of it. Here is how we describe our load balancer. The thing to note is what we call the resource and the title we give the resource. So you can see we have an AWS instance, and it's called load balancer. Similarly, we have AWS instance web server. And I've got 1 load balancer currently and 2 web servers for a total of 3, which is what we see in the console currently. So now that we know what's running in Terraform and how that's managed, let's figure out how to connect with existing resources using Bolt. So with Bolt, one way to manage it is to have a project directory. So you can see in my root directory here, webinar, I have 2 child directories, Bolter and Terraform. We'll move into the Bolt directory, and we'll look for a file called inventory.yaml. This is how we manage our connection information for remote targets. So the first thing we'll go over is this is a YAML file, and we have documentation that I've linked in the slides for general things. But at a high level, we're using version 2, and we are going to define groups that we can reference and dynamically load the targets in those groups through the Terraform plugin. So the first group is load balancer. Then we'll populate the targets with the Terraform plugin. In general, plugins have two main types of data you provide to them. The first, at the same level in Terraform, or excuse me, in YAML, is the parameters which are plugin-specific configuration. So for the Terraform plugin, the ones we need are the directory that the Terraform project is, which will be relative to the Bolt projector, the resource type. So this is AWS load balancer, which from the manifest, you can see that's the resource type here, maps 1-to-1. And then finally, the state file where this is managed. We will see more about state files as we get more into the plan code. These sort of configuration options, they are, you can think of as static, and then what is under target mapping is dynamic. So what will happen is we will go through the state file and we'll find every resource that matches to AWS load balancer, and then for every instance under that, we will go through and extract the public DNS and the host IP, and we will configure a new Bolt target with the name of the public DNS and then the SSH config for the host to connect to as the public IP. So quickly we will look and actually see what Bolt is doing under the hood here. As you can see, we've pointed it at the west init state.tf state, and so let's look at that file. Now this is a version 4 Terraform state file. You can see I'm using Terraform version 12.16, and you can see that this is structured data perfect for a tool like Bolt to parse. So you can see that under the AWS provider, we have the AWS load balancer here, and we can look for public DNS and public IP. In this case, it's at the top level in the attributes hash. In the documentation, you can see how to nest into nested config. So for example, there would be a way to have something under root block device volume ID if you needed that. So you can see that the web servers is almost the exact same config, except for the resource type is web servers. Now, the final part in this inventory file is both groups, the load balancer and web servers, will use the same config. In this case, it's configured to connect, make the SSH connection as the user Ubuntu, and then to run the task and plan and command content as the user root. This will allow us to make some of the configuration changes that we want. This is also an interesting feature of Bolt, that you can connect as a different user over SSH as you'd like, different from what you'd like to execute on. And then finally, we will use the private key that we've set up in the AWS provider. So let's see that in action. We'll use a Bolt command just to understand our inventory groups. So Bolt command run, we'll run the command hostname on -- targets, the name of the web server group. So you can see that we started on the name we gave those targets, which is the public DNS, and we connected to our 2 web servers, and it gave us back the host name. So we can also then know that we're targeting our load balancer. and we can see that. So what is our load balancer doing? Let's curl that to see what it's serving. So you can see the site content is hello from, and then the public DNS for one of the two web servers. So it's set up to just round robin between the two. So every time I make a request to the load balancer, it's balancing the load to one of the two web servers. So you can also see that the two web servers from the public DNS name are in the West data center. So let's start going into the Bolt plan code to migrate those. So what we have here is a Bolt plan. It looks somewhat like Puppet code, and most of the Puppet language features are in it, but it's actually an imperative sort of top to bottom language that you're maybe used to. So the first thing we're going to do is look at the parameters. So this plan takes two parameters, one called apply new with a hash of data, similar destroy old. So this we'll go over those. The first thing we're going to do is use the Terraform apply plan. So the Terraform apply plan is under the Terraform module, and it takes basically a mapping between Terraform CLI commands or CLI options to control Terraform and return structured data about the output. So under the hood, it basically just passes through to the task in the same module, the apply task. The apply task is run on, in this case, localhost, and the output is either returned if requested or not. So once we've applied our new Terraform manifest, then what we're going to do is discover it. So the way this works is very much like inventory. So you can see this looks almost identical to the YAML version of the hash. This is just a plan language version of the hash. So similarly, we have a plugin for Terraform, the directory relative to the project directory, the resource type, we're looking for the web servers because we applied two new web servers in the East Data Center. And the state file we will define in the apply new parameters hash. Again, here's the target mapping. This is the dynamic part. This will go through each instance attributes and pull out the specified key. So public DNS, same for name, public IP for SSH host. We will use the plan function called resolve references and pass it the references hash. This references hash will return an array of hashes. We will iterate over the array of hashes, and we will create new targets with that target hash. So this will allow us to add to our inventory and be able to connect to it. So the next thing, we will use the plan function wait until available, which is crucial for orchestration. Just because a new server is online and Terraform exits, that doesn't always mean you can immediately connect to it over SSH. I've seen it take anywhere between 2 and 30 seconds for everything to be in place and all the DNS, everything that has to happen behind the scenes for it to actually be available. So in this case, I configure it with a wait time of 60 seconds. So then we will configure the new web servers. So what this will do is run a plan that I wrote that will use, in my opinion, one of the most important parts of the plan language, which is an apply block. So what the apply block allows us to do is to write declarative Puppet code. So this is what you're used to seeing: a package resource, Nginx, then the file content, which we will just add an index.html with hello from the name of the public DNS name of the web server, and then we'll make sure that the service is running. And so that's what we're going to run to configure the web servers. Once that's done, we can run a plan to configure HAProxy, which is the load balancer we're using. So this plan, we use both the apply to apply declarative Puppet code, as well as some imperative logic. In this case, what we're doing is we are getting the balance members and extracting the data we need from them to pass across the apply boundary. So once we've done that, we will have added the new web servers to the balance members of the load balancer, and we will be safe to destroy the old web servers. So let's go ahead and run that plan. So this is a plan action. So you can see it's going to the first task, and the first task is to Terraform apply on the target local host. So what this is doing is requesting that Terraform brings up 2 new servers in the Eastern Data Center. While that's running, let's look at what the params were for that. So the params were, for apply new, we're giving it the Terraform directory from where to execute that Terraform apply from. Then var file, so this is what's going to actually go in and fill all the variables for that HDL manifest. So for example, the secret key here, the region, and so forth. And then also the target. So we only wanted to apply the change to, or we only wanted new web servers. So that's the target resource. And then finally the state out. So this is where we want to manage our those sort of state for those East web servers. So while we were looking at that, we see that the apply, Terraform apply, task finished with no failures in about 40 seconds. Then we're waiting for available until the new targets. So this is EC2 in US East, and similarly another one in US East. So at this point, we have 2 brand new instances in the East Center, and we will ensure that we connect to them. Once we're ensured we can connect to them, then we have the plan to configure the web servers. So again, this is basically just installing Nginx, writing some content to index.html, and making sure that the service is running. Then once that is done, we run the configure HAProxy, which ends up removing the old web servers from the Western Data Center and replacing it with the newly configured ones from the Eastern Data Center. Then once that's done, we can safely destroy our old nodes in the Western Data Center. So if we go ahead and curl our load balancer, we should be getting served from the Eastern Data Center, and we are. And then finally, we can check our AWS console and make sure that the nodes were destroyed that we think they were, and the newly ones are provisioned. So you can see we have 2 terminated nodes from the Western Data Center, and we have 2 new running in the Eastern Data Center. So we have 3 minutes. Simone, do we have any questions here?
Yes, we do. So first question from James, can you base the Bolt command run hostname targets on AWS tags? For example, if I want to check a specific set of web servers that have a specific tag.
Are the tags in the state file at all? Do you know? I'm not exactly sure on that, but if you can look at the AWS module itself, that seems like something we could easily add. And so, yeah, if you wanted to file an issue against either the Bolt project or the Terraform one, this is very much a new module, and we're hoping that the community contributes to it, and we get ideas like that to help people who are struggling with, orchestrating Terraform stuff.
Thanks. Next question is, what other inventory plugins exist?
That's a good question. So inventory plugins, what we found when we were writing them is it really just looks up data. So what currently exists today and what we ship with Bolt is Terraform, AWS EC2. So that's a different way of connecting without looking at Terraform state files. If you were just managing things in AWS and their EC2 instances, we have one for Azure. We have one sticking with the HashiCorp vibe. We have one for Vault. And then we have just a pure YAML one, so you can just reference another YAML file. We have one built in for PuppetDB, so you can execute PuppetDB queries to populate your nodes or your targets. And then we have some for just prompting for data, one that'll just collect data on standard in. And then we have one for PKCS7 encryption. And the list is growing, and I know that people are writing their own, which is really exciting. I've heard one for Active Directory for Windows stuff. But yeah, that's, I think, all that exists and are currently shipped with Bolt now.
Great. Well, we are almost at time. I think we've got about 30 seconds left. There are a couple of questions that we didn't get to, but we will follow up with anyone who has an unanswered question via email. So don't worry, you will get your question answered. And I do see a question about whether or not this is being recorded, and it is. So we will be sending out a link to the recording and to the slides within the next few days. And with that, thank you everyone very much for attending, and we hope you go try this out for yourself.
Thanks, everyone.
Thanks. Bye.